Welcome back. I am Grandpa. You are watching Grandpa Mathematics. Today let us see how to find the general solution of linear differential equation. An equation of the form dy by dx plus py is equal to q, where P and Q are functions of x or constant. This is the first order linear differential equation. dy by dx is the, so the order of the differential equation is 1. So this is a first order, and the degree of the differential equation is 1. Therefore this is a first order linear differential equation. And we have to see how to find the general solution for this first order linear differential equation. Here P and Q both are functions of x or constant. Now to find the general solution, first we have to find the integrating factor. What is integrating factor? It's nothing but e power integral p dx. P is here. You have to find the value of e power integral p dx. We have to find the value of this, multiply the equation 1 by the integrating factor we get. Now the left hand side becomes d by dx of y into integrating factor. So this is equal to e power integral p dx into q. On integrating we get the left hand side becomes differentiation. Integration is the inverse process of differentiation. So on integrating this left hand side we'll get y into e power integral p dx. The right hand side integral e power integral p dx into q dx. Now p and q both are functions of x or constant. We have to evaluate this integral, then we can find the value of y. So this is the general procedure. So given the differential equation, first we have to write in this form and see that p and q both are functions of x or constant. Then only you can follow this method. Then find the integrating factor, that is e power integral p dx. Then multiply this equation by the integrating factor. Then the left hand side becomes d by dx of y into integrating factor. On integrating we get y into integrating factor is equal to integral integrating factor into q into dx. We have to evaluate this integral. We have to find the general solution of this first order linear differential equation. On comparing this with dy by dx plus py is equal to q, we will find the value of p is 2. So what is integrating factor now? It's equal to e power integral p dx. P is 2 here, so 2 dx. This is equal to e power integral 2 dx is 2x only. Here we need not write the constant. So multiply the equation 1 by e power 2x, that is integrating factor we get. The left hand side of this equation becomes d by dx of y into integrating factor. Integrating factor is e power 2x. So this is equal to e power 2x into sin x. On integrating we get, so before that we will differentiate and see whether we are getting this term. So this is a uv form, so y into, if we differentiate e power 2x, e power 2x into 2 will come. So y into e power 2x into 2 has come, this term. Then e power 2x into dy by dx, e power 2x into dy by dx. So that means this we can write in the form of d by dx of y into integrating factor. In integration is the inverse process of differentiation. So the left hand side becomes y into e power 2x. This equal to integral e power 2x into sin x dx. Now we have to evaluate this integral, then we can get the value for y. Let us take this equal to I, say equation 2. So I is equal to integral e power 2x into sin x dx. How to evaluate this integral? Integral e power 2x into sin x into dx, integration by parts. So we out of these two we can integrate any term. So here we will integrate e power 2x. If we integrate e power 2x, what will come? E power 2x. If we differentiate 2x, 2 will come. So by 2 into second term, other term sin x minus integral of integrated term, that is this one. Into differentiation of the other function. We have to differentiate and write there. If we differentiate sin x, cos x will come dx. So we have integrated this, other function we written minus integral of integrated function, this we written here. Then we have to differentiate and write here. Now e power 2x by 2. So minus is there, half is there. Again, if we integrate this integration by parts, 2 terms will come. So we'll use the bracket. Again, we'll integrate e power 2x. So we'll get e power 2x by 2, second function cos x, minus integral of integrated function e power 2x by 2 into differentiation of the other function. If we differentiate cos x, minus sin x will come dx. Now this will be e power 2x into sin x by 2 minus 1 by 4 times e power 2x into cos x minus into minus plus into minus minus 1 by 2, again 1 by 2 is there. So it will be 1 by 4 integral e power 2x sin x dx. So see here, minus 1 by 4 times integral e power 2x into sin x dx. So this is nothing but, again, is nothing but I only. I is nothing, integral e power 2x sin x dx, integral e power 2x sin x dx. So how to proceed now? Just we have to replace this with I. Now take this term to the left hand side. I plus 1 by 4i, that is 5 by 4i, this is equal to, you can take e power 2x, 1 by 4 is there, e power 2x by 4, then 2 sin x minus cos x. Therefore, I is equal to e power 2x by 5 into 2 sin x minus cos x. Therefore, equation 2 becomes y into e power 2x. Y into e power 2x is equal to I. I is nothing but e power 2x by 5 into 2 sin x minus cos x plus c. Now what the value of y now? We'll divide throughout by e power 2x. This gives the value of y is equal to 1 by 5 times 2 sin x minus cos x plus c e power dividing by e power 2x, e power minus 2x. So this is the answer. This is in the form of dy by dx plus py is equal to q, where p is constant 3 and q is e power minus 2x, functions of x. We have to find the integrating factor. Integrating factor is e power integral p dx. P is 3, so 3 dx. So integral 3 dx is 3x only. Now multiply the equation 1 by the integrating factor, we get. Now the left hand side becomes d by dx of y into integrating factor. So this is equal to, integrating factor is e power 3x. This is equal to e power 3x and e power minus 2x is e power x. On integrating we get y into e power 3x. This is equal to integral e power x dx. If we integrate e power x, what will come? E power x only. E power x plus constant. Therefore, the value of y is equal to e power x by e power 3x, that is e power minus 2x, plus c, if we divide c by e power 3x, e power minus 3x. So this is the answer. So this is the general solution for this differential equation. UV form, if we differentiate y into e power 3x, y into, if we differentiate e power 3x into 3 will come. So e power 3x into 3 into y, so we are getting this term. Then e power 3x into dy by dx, e power 3x into dy by dx. So on comparing this with the dy by dx plus py is equal to q, we'll rewrite this equation dy by dx plus 1 by x into y is equal to x square. Here p and q both are functions of x. P is 1 by x and q is x square. So what is integrating factor? E power integral p dx. E power integral p is 1 by x here. So 1 by x dx. So this is the integral dx by x. So we know integral dx by x is log x. So e power log x. And we also know that e power log x is x only. So it's x. So multiply the equation 1 by x, we get so the left hand side becomes d by dx of y into integrating factor. Integrating factor is x, so y into x. So this equal to x cube. On integrating we get y into x, this equal to integral x cube dx. This is in the form of integral x power n dx. So x power n plus 1 by n plus 1, x power 3 plus 1 by 3 plus 1, x power 4 by 4 plus constant. Therefore, y is equal to x cube, we are dividing by x cube by 4 plus c into x power minus 1. So this is the general solution. Again, if we differentiate xy, y into, if we differentiate x is 1, y only, so we are getting y. X into, if we differentiate by dy by dx, x into dy by dx. So on comparing this equation with the dy by dx plus py is equal to q, we get p is secant x and q is tan x. Both are functions of x. So what is integrating factor? E power integral p dx. E power integral p is nothing but secant x here. So secant x dx. So e power, what is integral secant x dx? Is nothing but log of secant x plus tan x. Again, we know that e power log x is x only. So this is nothing but secant x plus tan x. So multiply the equation 1 by the integrating factor. It is the secant x plus tan x we get. Now the left hand side becomes d by dx of y into integrating factor. Y into integrating factor is secant x plus tan x. So this is equal to, we'll multiply this secant x into tan x plus tan square x. Now d by dx of y into integrating factor, if we differentiate y into secant x plus tan x, this uv form u into, that is y into, if we differentiate secant x plus tan x, what will come? If we differentiate secant x tan x will come. So secant x and tan x is there. If we differentiate tan x, secant square x will come. Secant square x is there. Y. So this is second term. Again, secant x plus tan x into, if we differentiate y with respect to x, dy by dx. Secant x plus tan x into dy by dx. So on integrating, we get y into secant x plus tan x, this equal to integral secant x into tan x. So we know integral secant x tan x, but we don't know, there is no standard formula to integrate to find the integration of tan square x. So we have to write tan square x in terms of secant square x. So this will be secant square x minus 1 into dx. Now, if we integrate integral secant x tan x is secant x. If we differentiate secant x tan x will come. If we integrate the secant square x, what will come? Tan x. If we differentiate tan x, secant square x. Tan x minus x plus constant. So this is a general solution for this differential equation. So we have to find the general solution of this differential equation. This is not in the standard form. So we have to write this in the standard form of dy by dx plus py is equal to q. So we will divide throughout by cos square x, we get so 1 by cos square x we can write as a secant square x. Now, on comparing this with dy by dx plus py is equal to q, we get p is secant square x and q is secant square x into tan x. Both p and q are functions of x, and we have to find the integrating factor. Integrating factor is e power integral p dx, e power integral p secant square x dx. So e power, if we integrate secant square x dx, what will come? Tan x. So e power tan x. So this is the integrating factor. Now multiply the equation 2 by integrating factor, that is e power tan x, we get now the left hand side becomes d by dx of y into integrating factor. Integrating factor is e power tan x. This is equal to e power tan x into secant square x into tan x. On integrating we get left hand side is y into e power tan x. This is equal to integral e power tan x into secant square x into tan x dx. Now we have to see how to evaluate this integral. E power tan x is there, secant square x is there, tan x is there. So we know that if we differentiate tan x, what will come? Secant square x will come. We take tan x is t, secant square x dx becomes dt. So let tan x is t, then if we differentiate we get secant square x dx becomes dt. Therefore, equation 3 becomes y into e power tan x is equal to integral e power tan x is t, tan x is t, e power t, tan x is again t, secant square x dx is dt. Now we have to evaluate this integral. If we differentiate t with respect to t, we get 1. So that means we'll integrate e power t and we'll take t as the other function. We'll integrate this by integration by parts. If we integrate e power t, what will come? E power t only into second function t minus integral of integrated function e power t. If we differentiate t, 1 into dt. So this becomes now e power t into t. If we integrate e power t with respect to t, we'll get e power t only plus constant. But what is t? T is nothing but tan x is equal to e power tan x into tan x minus e power t, e power tan x plus constant from 4. Now e power tan x, we'll divide throughout by e power tan x. We get so this is the general solution.